Hey all you cool cats and kittens, this is Miss Bartels teaching today's lesson on volume of pyramids and cones. So just the past Wednesday and Thursday you've been working on volume of cylinders and prisms, so it's no different other than we are focusing on pyramids and cones. So just a quick refresher, volume of a solid is just that space inside a 3D figure. So a lot of times when I'm thinking of volume, I think of the water you fill up in a pool. All of that water on the inside would be considered your volume. Okay, moving on to the formula. It probably looks very familiar. The volume of a pyramid and cone, the only difference is you have this 1/3 right in front. And you multiply by that 1/3 by the area of the base and the height of the prism or cylinder. So we can make that even more specific when we're dealing with a cone. So if you think about a cone, we have the base of a circle. So let's talk about this area of a base. Well, the area of a circle is found by pi r squared. So the volume of a cone is found by 1/3 pi r squared times the height. So let's look at our example below and go ahead and see what we have. Well, we know the radius is 8. Do we know the height? Well, some of you may have wanted to say 17, but that's actually our lateral height. That's not the same as our actual height. So if you look at what I drew there, let's draw that off to the side. What do we have? We have a right triangle. So we have the hypotenuse of 17, the base of 8, and we are trying to find this height. So we can use our Pythagorean theorem. So 8 squared plus 8 squared is equal to 17 squared. I know 8 squared is 64, and I know 17 squared is 289. Now we go ahead and subtract that 64 from both sides, and you get h squared is equal to 225. Last step, square root both sides to get rid of that square, and you get h is equal to 15. So our height here is 15. Now all we have to do is plug it right into that volume formula, and we get 1/3 pi 8 squared times the height. So let's hop on over to our calculator and plug all of that in. So we have 1/3 pi r squared times the height. So we get 1005.31. And that is in feet cubed. There's our volume of our cone below. On to the next problem. We have a pyramid. So we're going to rewrite our volume formula, 1/3 area of the base times the height. If you would like to try it on your own, pause the video here. Otherwise, let's go ahead and solve for that area of the base. Well, our base is a square. So we just have to do our 9 times 9, and that gives us 81. And our height is given at 10 meters, right here. So let's plug that right into our volume formula. We get 1/3, 81, times 10. Hop on over to the calculator. 1/3 times 81 times 10, we get 270. So our volume is 270 meters cubed. Last problem, but before you pause the video to try on your own, I want you to notice at the bottom it says the base is an equilateral triangle with the length of 5 centimeters. So use this equation or this formula from the handy dandy scroll to help you find that. So that is s squared square root of 3 over 4. and that will get you your area of the base. So if you would like to try 3 on your own, go ahead and pause the video here. Otherwise, let's get started. Volume is equal to our 1/3 area of the base times the height. The height is already given at 19. We just have to find the area of the base. So let's use this formula right down here and plug in that 5. So 5 squared, square root of 3 all over 4. Five squared times the square root of 3 all over 4. And we get 10.825. For our base, area of the base. Okay, let's plug that right into our formula of 1/3 10.825 times 19. So we have our 1/3. I am actually going to click this answer button because that will transfer the entire decimal into that, and using all of the decimal places will give you more of an exact answer than if you were to round. And then we type in our height, and that was 19, I believe. We get 68.56. And we are in centimeters cubed. There is our volume of that pyramid. Okay, I'm going to zoom out here. If you would like to copy these notes down, I would pause the video here. Otherwise, we are going to hop on over to the next page and work on some more problems. So, this one says, use the formulas to find another dimension. If a cone has a volume of 681 cubic inches and a height of 8 inches, find the radius. Well, we're dealing with a cone, so I'm going to write my volume formula for a cone up at the top. So 1/3 pi r squared times the height. And plug in everything you have. So let's see, the volume is 681. And then we have 1/3 pi r squared. It looks like the radius is what we're finding, times the height, so times 8. Hey, some of you may be stuck with how to solve for r from here. I'm going to show you how to simplify it. Multiplying by 1/3 right here is the same as dividing by 3. So it's easier if you were just to rewrite it as 1 pi r squared times 8 all over 3. Okay, let's simplify this numerator more by multiplying the 1 and the 8. So then we have 681 is equal to 8 pi r squared, all divided by 3. And the reason to me dividing by 3 is easier than multiplying by 1/3 is because we can put 681 all over 1 and cross multiply. Anything multiplied by 1 stays the same, and then 681 times 3 gives us 2,043. Next step would be to divide by our 8 pi, so it cancels out over here, and divide by 8 pi. Hop on over again. Answer divided by 8 pi, and we get 81.288 is equal to r squared. Our last step would be to square root it to cancel out the square. Hop back over. I'm going to square root, and I'm just going to click that answer so it copies it, and we get 9.02 rounded. So R is equal to 9.02. And we are in inches. Okay, there's our radius. Okay, on to the next. It says find the volume of the compound solid. So it looks like we have two parts. We have a prism at the bottom, and we have a pyramid at the top. Kind of looks like a house. So if you would like to solve it, I recommend solving it in two separate pieces and then adding that together. Otherwise, let's solve it together. So let's find the prism first. Well, the volume of a prism is length times width times height. This one actually looks like a cube, so it's going to be 7 times 7 times 7, or in other terms, 7 cubed. Let's find what that is. 7 times 7 times 7 is 343 inches cubed. So the area of this part is 343 inches cubed. Let's switch on over to find the pyramid. And remember, the volume of that is 1/3 area of the base times the height. Well, the area of the base is still this square. So the B is going to just be that 7 times 7, and that will give us 49. And our height is also 7. A lot of 7s in this problem. So let's plug it all in. We'll have 1/3, 49 times 7. And you get 114.33 inches cubed. Okay, so that gave us our pyramid. Now to find the whole thing, we just add them together. Let's go back, take our answer, and add our 343. We get 457.33. Inches cubed. Okay, last problem. It says the shape of the cylinder with a cone hollowed out on the inside. Height of the cylinder is 9. So let's write that down. Height is 9. And the radius is 8. So if you would like to solve this on your own, I recommend taking the cylinder volume and subtract the cone, because the cone is what's hollowed out. So that would be how you solve for this problem. Otherwise, let's get started with finding the volume of the cylinder first. So the volume of the cylinder is base times height. And since a cylinder has that circular base, it is technically pi r squared times the height. So in this case, our radius is 8, our height is 9. Plug all of that in. We get 1,809.56. Centimeters cubed. Okay, and now let's find the volume of the cone. So volume of a cone, only difference is we have that 1/3, and that's pi r squared times the height. So plug everything in, and we get pi 8 squared times 9. Go back to our calculator. So we get 1/3 pi 8 squared times 9, and you get 603.19 centimeters cubed. Last step was to subtract the 2. So I'm going to take my 1,809. I'm going to copy down all those decimals just to keep it more accurate and subtract the answer of 603.18. And we get 1,206.37. And we are in centimeters cubed. Okay, so what that just found us is all of this that we did not hollow out. And since that cone's hollowed out, that's an empty space. Okay, I'm going to zoom out for you to look at the whole page of notes. Okay, that's it for today. If you have any questions, feel free to reach out to any of your teachers for extra help. Otherwise, on Monday, you will have a Go Formative to work on. Thanks for listening.